So based on the way the normal curve approximates data values, you can look at the picture of the curve right here. Remember, we said that 68% of the data was located one standard deviation away from the mean. So this is the 34% that's above the mean and the 34% that's below the mean. And that's located one standard deviation away from the mean. Within two standard deviations from the mean, those data values following the rule from the front of your notes said 95%. So if 68% was already from here to here, this is the other 27% that would get you to 95. And then the last pieces over here would get you to your 997. So this extra 2.35 and 2.35 would get you to where you were going. So this is basically just taking the normal curve and the numbers we practiced on the front, but it's breaking them up into these pieces. So if you count on your graph, there's 1, 2, 3, 4, 5, 6, 7, 8 pieces under the normal curve. And if you add up all of these percentages, they're always going to add you up to get you to 100%. So these word problems that we're going to do today are going to assume that the data are normally distributed. So that's the words you're going to want to be looking for in the directions when it says normally distributed. That's how you know that it's following this pattern of how the data values are spread out. So because this is so difficult to understand the first time that you're going through, well, not just the first time, but when you're going through and learning it, we're going to draw this normal curve. Mine won't be perfect, but they will be good enough on each of the examples that we do. Let me come down a little bit closer here on the notes so that it's easier to see the stuff that I'm writing. There we go. All right, so we're going to do this example right here. So I'm going to continue drawing this curve throughout the notes so that we can check the numbers that are 1, 2, and 3 standard deviations away from the mean. Suppose the heights in inches of males in the United States between the ages of 20 to 29 are normally distributed. So that's what you're looking for, because normally distributed means that it's going to follow this curve. It tells you that the mean is 96.3, just kidding, 69.3. So that's going to go in the middle. That's going to be mu, or your average. And then it says that the standard deviation of 2.92 inches. So that means that one standard deviation away is 2.92. So this is going to be whatever the average was plus 2.92. And then plus another 2.92, and then plus another 2.92. So on your papers, go on ahead and draw something that kind of looks like the normal curve. That wasn't that bad, actually. And then I'm going to draw in the 8 sections of the graph. So this is where my average is going to go right in the middle. And I'm going to have 1, 2, 3, and then the last part. And then on this side, I'm going to have the same thing. Totally not perfect, but what I'm trying to do is make sure that I have these lines. There's going to be 7 lines for the 8 sections, so I can write the numbers on. And then I'm going to go ahead and turn my paper sideways so that it's easier to write on in the numbers for this one. So in the question, it says that the mean is 69.3, so we're always going to put that right here in the middle. So that's the average of the heights of males that are between ages 20 to 29. And then it says that the standard deviation is 2.92. So for each one of these lines as they go across the page, on this side I'm going to subtract the 2.92, and on this side I'm going to add the 2.92. So that one's going to be 66.38, and then 63.46. So these numbers go with where the lines are located. And then on this side, I'm going to add the 2.92, 72.22, 75.14, and then 78.06. So those that I just drew in right there mean that as long as the person's height is in between 66.38 and 72.22 inches, that's within one standard deviation from the mean. So one above and one below. If it's within this one and this one, that would be within 2 standard deviations from the mean. And the percentages are going to match up to these percentages. So these numbers are going to be the same numbers all the time. This question wants to know, find the percent of males that are shorter than 66.38 inches. And so 66.38, if you notice and you look on your paper, that's one of the numbers. All of these problems are going to be rigged or set up so that the number that they give you is going to be one of the numbers that are down here on your normal curve. So they're always going to work out for you today. So the percentage of males that are shorter than 66.38 inches, well, that would be anybody that was less than this. So that would be this section of the graph, this section of the graph, and then this section of the graph over here. So to answer the question, I'm going to go back up to my normal curve, and I'm going to match this up. So this was the middle, right here. This would have been the 34% bar, but they just want to know these numbers over here. So to find my answer to this question, I'm going to add up 13.5 with 2.35 and with 0.15. So I'm just adding up the percents that match up to the ones that I've colored in here on my graph. And so for this one, when I add those three numbers up, I get 16. They want me to write the answer as a percentage, so I'm going to write it as a percent. And so the answer to the question is, with the given information in the question, 16% of males would be shorter than the 66.38 inches that was indicated, since it follows that normal curve. And so this number and these numbers come from looking up here at this picture. So you're always going to go back to this picture. And before you worry about it, yes, you'll be given this picture when you take the quiz on this, chapter 21 stuff. So there we go. So all of the problems for the rest of this follow that same pattern. So we're going to be doing the same thing over and over again to answer the question. There's going to be a little bit of difference in how we interpret each answer, but we're going to stick to the same thing. So I'm going to draw my sort of normal looking curve, and then I'm going to cut it into the 8 pieces that I cut it into. In this problem, it says, suppose the heights in inches of men ages 20 to 29 in a country are normally distributed. So again, they're normally distributed, which is good because we need that to happen in order to be able to use this pattern. It says on this one, the mean, though, it's not 69.3, it's 69.5. And the standard deviation isn't 2.92, it's 2.63. So I'm going to do the same thing I did before. I'm going to write my 69.5 in the middle. And then instead of adding the number that I added previously and subtracted previously, I'm always going to add and subtract the standard deviation. So this 2.36 is the number I'm going to subtract on this side, and then I'm going to add it on this side. So 69.5 is my middle. This one's 66.87, and then 64.24, and then 61.61. So those are the values I get when I subtract the 2.63 over and over and over again. And then on this side, I'm going to add it 3 times to the number 2. 72.13, 74.26, and 76.89. Because you don't know which ones you're going to need before you start the question, I like to just go through and write all of them in. If you can look at these numbers and kind of think about where they're going to be on the graph, you might start to be able to predict how many standard deviations away from the mean you're working with, but that just depends on how comfortable you are with the numbers, so it's kind of up to you to decide. This one wants us to figure out what percent of men are between 66.87, so that's 1 standard deviation to the left, and then 72.13, so that's 1 standard deviation above. So remember, notice how these numbers are always going to be the numbers that you have that are marked for the standard deviations. So for this one, I have a left limit and a right limit. I'm trying to figure out how many are between these two values. When I go back up to my picture, these 2 bars are the 34 bars. And so when I find my answer for this question, I'm just adding up the probabilities or the percentages of them being in that area. So 34 and 34 is going to give me 68%. So for this one, with the given information, there would be 68% of men would be between that height. All right, and so we're going to rinse and repeat for this last one as well. This one says they give you a different mean. Well, that's not really a normal curve, but it's going to serve the purpose. So there's my 34s, there's my 13.5s, and then there's my 2.35s. And so on this problem, with this not so normal looking curve, they say that the mean on this one is 69.5. And then the standard deviation is 2.93. So I'm going to add and subtract my 2.93 on this one to either side. So that's going to be 66.57, 63.64, and then the last one's going to be 60.71. So I just subtract the 2.93 3 times from the mean, and then I'm going to add it 3 times to the mean on this side. 72.13, 74.26, and then the last one is 76.89. So on this final question, with these same situation about the heights of how tall the people are, it says that they're normally distributed, and it wants us to figure out the percentage of men who are shorter than 75.36. 75.36. Oh, so right here, these values are incorrect. I wrote down the numbers from the previous problem instead of for this one. So I was adding the wrong mean to it. So just adjust those on your paper. So this is 72.43, 75.36, and then the last one is 78.29. So those are the numbers that you get when you add this number over and over again. It's actually helpful for me to point out that I knew that the numbers had to be wrong that I had just written down, because the number that they give you right here, if you're using the percentages of the way the normal curve is distributed, this number that they give you is always going to be one of these numbers here. And if it's not, it means that you set your normal curve up wrong. So they want to find out the percentage of men who are shorter than this height. And so that height's right here. So I'm going to be adding up this bar, this bar, this bar, this one, and this is super important to point out. Everybody always forgets this little piece over here, the 0.15 that is over here as well. So you might want to make a note on your papers that says not to forget that, because this one right here, don't forget me, is the one that everybody always neglects to include. So if the question had said the percent of men who were taller than this, I would have just been adding up these two pieces. But because it says shorter, I have to add up 1, 2, 3, 4, 5, 6 numbers. So it's just these two that I'm not including. So when I add up the numbers on this one, I'm going to be adding up 13.5, 34, 34, the other 13.5, the 2.35, and the 0.15 that everybody forgets. So that's a super common mistake to make. And when I go through on this one, and when I add up those 6 numbers, I get 97.5. And they wanted me to write it as a percent. So there's 97.5. So basically everybody, almost everybody, are shorter than this height. Before we move on to the next part, I want to give you kind of a hint about how you can check your answers for these. When I look at this, I'm going to ask myself the question about how much of this curve is shaded. It looks like not a lot, like maybe a quarter. Well, it's 16% of the curve that's shaded. So this means that there's not a lot of people that are shorter than the 66.38 inches that's indicated in this question. When I do the next one and I look at how much of it's shaded, well, it's only 2 bars, but they're the 2 biggest bars. It looks like it's more than half. And so when you look at your answer right here, it is more than half. It's 68%. So your answer should kind of feel like about how much of the graph is shaded in, about how much of the normal curve is shaded in. For this one, you shaded in almost everything besides this teeny little bit over here. And so that means that almost everybody, or most of the people being included in the study or in the survey are. And that's good because this is almost 100%. If both of these were colored in, it would be 100%. But for this 97.5%, it means that almost everything is shaded in, and it's good because it feels like almost everything is shaded in. So the one thing that you want to keep in mind when you're doing these is that you have to be able to look at them and see, are they talking about being greater than something? Are they talking about being less than something? Because that's going to tell you whether you shade to the right or whether you shade to the left and like which ones you're looking at. So keeping that in mind, that'll be helpful. But these 3 problems gave you 3 examples of that were, they did a really good job about seeing the different things that were on your paper. So for the last column for the notes for today, the questions are all set up in a similar manner. This next example says, a college entrance exam is designed so that scores are normally distributed with a mean of 500. So 500 is going to be my middle, and a standard deviation of 100. So on this one, when I draw my normal curve, I'm going to do the same thing that I did on the last problem. Let's see how I do drawing this one. Oh, it's a little better. But on this one, when I cut it into my 8 pieces, my middle is going to be 500. And then when I do 1, 2, 3, and 1, 2, 3, those are each going to go up by 100 on this side and down by 100 on this side. So on this one, my middle is 500, and then this is 4, 3, and 200, and then this way it's going to be 6, 7, and 800. And it's still going back to the same normal curve. So they want to know for this one, since it's normally distributed, that means that I can use this normal curve that I've been using so far. They want to know what percent of exam scores are between 300 and 700. So 2 standard deviations below the mean and 2 standard deviations above the mean. So when I go back to my table or my original picture, that's the 13.5 column. That's the 34 column, that's the 34 column, and that's the 13.5 column. And so when you add up those numbers for this one, they also want the answer written as a percent, so I'll write it as a percent. So that's 95 when you add those numbers up. Almost all of them, all but 5% of them. This little piece over here and this little piece over here are the only two that aren't included when you consider this one. So again, you're thinking about how much of the graph is colored in, and does this number feel like it's the right amount towards 100? It's a nice way to check your answer. What is the probability that a randomly chosen exam score would be below 800? So here's my normal looking curve. Cut it into my 8 pieces. It's going to have the same numbers as before. Because these questions all go back to the same information, you probably could use the same picture and just think about coloring in the different places, but for your notes for today, I'll go through and I'll rewrite them so that you have a picture that represents each one. So for this one, they want to know what's going to happen, or what would be the probability that it would be below 800. So below 800 would mean this one, and 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 then don't forget this one over here too. And so you guys, when you're doing this one, you're allowed to add up this piece and 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 this piece. What some people do is they'll take the total and they'll just subtract this part from it. And so you're also allowed to do that too. But if you follow the adding pattern, you're going to be adding 0.15. That's the part over here that you're not going to forget. 2.35 for this part. 13.5 for this part. The 234s in the middle. The other 13.5 for this part, and then this one's the last one that you add up is 2.35. So you're adding up everything besides the 0.15. So subtraction would be much faster here. When you add all of those numbers up together, you get 99.85. And so if the question said what percent would be below 800, you would write 99.85%, but this question is worded a little differently, and it says, what's the probability? Make a note on your paper that reminds you that probability is always a value between 0 and 1. So whenever you see the word probability, it's always between 0 and 1. So it's always going to be a decimal since it's always between 0 and 1. So to turn this number into a decimal, I'm going to take the decimal point and I'm going to move it 2 places to the left, 1, 2. And so my answer for this question that I squished in this line, it's not going to be 99.85. It's going to be 0.9985, and I'm not going to put the percent symbol. So 0.9985 is the answer to that question. So it's just because it said probability instead of saying percentage. So like the next one says probability, so I'll have to do the same thing on the next one and convert it to a decimal. All right, so for this one, it's the same example with the test scores. So I'm going to break my graph up into the 8 pieces. Here's my 500 in the middle. And then 600, 700, and 800. So for this one, they want to answer the question, what's the probability that a randomly chosen exam score was less than 200, so that's just this piece over here, or greater than 800? Whenever you see the word or, it means that you're going to have to consider the 2 pieces separately. So the probability that it would be over here would be 0.15. The probability that it would be over here would be 0.15. And so if they wanted me to write it as a percentage, it would be 0.30%. But it's tricky because they want me to write it as probability. So I need to take the 0.30. I'm going to move my decimal point 2 places over to the left. And so this empty space that's right here, I'm going to need to fill that in with a 0. And so when I write my answer down, it's going to be 0.0030. 0.0030. You're allowed to drop the 0 at the end if you choose to do so, but you're not allowed to drop either of these zeros because they indicate the place holding of this. Comparing the answers to these 2 questions, this one is almost 1, this one is almost 0. And that makes sense because if you look at the pictures of the graphs, almost all of this curve is colored in underneath it. On this graph, on this curve, there's only this little piece over here and this little piece over here that are colored in, which means that this event is much more likely to happen than this one is. And that's why this one's almost 1, because this is almost everything, right? But on this one, it's almost nothing. And so that's why this one's closest to 1, and this one's really close to being 0. It's almost like it couldn't happen, but it could, but it's just not really likely. All right, same thing, rinse and repeat for this last one. It says there's a flight coming in and the arrival time is normally distributed with a mean arrival time of 8:30. So on this one, when I draw my curve, my middle right here is going to be the time 8:30. And then it says that the standard deviation is 15 minutes. So when I do this one, I'm going to be adding 15 minutes and subtracting 15 minutes to get those numbers, adding and subtracting 15 minutes to get those numbers, and then adding and subtracting 15 minutes to get those numbers. So if 8:30 is the one right in the middle, this one's going to be 8:15 and 8 o'clock and 7:45. And then this way is going to be 8:45, 9 o'clock, and 9:15. And so they want to know if it's normally distributed. It says in the question that it is normally distributed, so it indicates that right here. They want to know what's the probability probability, so not percent. So I will write my answer as a decimal, not with a percent sign. What's the probability that a randomly chosen arrival time is after 8 o'clock? So I find 8 o'clock. 8 o'clock is 2 standard deviations below the mean. So I'm looking here, 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 and then here too. I know I'm being silly with this, but don't forget, because it's super easy to forget that little piece over there, and your answer would be 1.15 off from what it should be. Most of this is colored in. I'm expecting that this is going to be pretty close to the number 1. I just have to make sure that I add up the right numbers. So this bar right here, 13.5, 34 and 34, 13.5, 2.35, and don't forget the last part. So I'm going to add up those numbers together. And when I add all of those numbers up, I get 97.5. If it wanted it as a percent, I would keep it like this, but because they want it as the probability, I'm going to move this 2 places over, so 0.975. It's cool that this number, it's not really cool, it's good that this number is really close to the number 1, because that number right there that you get on your probability means that most of the curve should be colored under, and it is. It's all besides these 2 parts over here that are colored in, so it's good that that number is really close to 1. And then here we go. Same picture, but I'll draw it out so that you get this one colored in on its notes as well. Oh, that's pretty bad. 1, 2, 3. 1, 2, 3. So here's my 8:30 in the middle. 8:15, 8 o'clock, and 7:45. And then it's the same thing, but I'm adding on the other side. So 8:45, 9 o'clock, and 9:15. So this one says, find the probability that the randomly chosen arrival time is before 8 o'clock. So that's this one, and don't forget that one. Or after 9:15. So that's this one over here. So I'm going to do it again. Sorry, guys. Don't forget. And don't forget. So there's 3 numbers that you have to add up on this one. Before you add them up, look at the curve. Most of it is not colored in. So you're expecting that your probability would be low for this because there's only these little places over here and this little place over here that it could happen. So when I add up my numbers, I'm adding up 0.15. The next one's 2.35 and the other 0.15. So when I add up those numbers on my paper, I get 2.65. If they wanted me to write it as a percent, I would write it as a percent, but the question instructs us to write it as a probability. So I'll move my decimal point 2 places over. I'll fill in a 0 right here where there is not one. And so my probability is going to be 0.0265. It's basically 0. It's super, super small because there's very few ways that a randomly chosen flight would be before this time or after this time. And so I do definitely recommend looking at your normal curve after you answer each question to figure out if it feels like the number that you're getting as a number here should be a big number that's really close to the number 1, or if it should be a small number that's really close to the number 0.